You are looking at the screen of a Dorado personal workstation running the Cedar programming environment. Occupying the left column of the screen is a gargoyle graphical editing window with a picture in it. In the right column is a MatchTool window. The MatchTool provides a fill-in-the-form style interface for specifying graphical search and replace operations. In this videotape, we will use the MatchTool to modify a number of graphical scenes. In the lower part of the gargoyle window, we have a map of some of the major freeways in the San Jose area of California. We will use the MatchTool to change some of the local Highway 17 signs to Interstate 880 signs. I will load a description of this replacement into the MatchTool and use the MatchTool to make the change. We want to search for all Highway 17 signs, so I select one of them and copy it into the search pane, that is the left pane, of the MatchTool. Then we want to replace the Highway 17 signs with Highway 880 signs, so I select the Highway 880 sign, and before I copy it into the MatchTool, I position it with respect to the Highway 17 sign. This tells the MatchTool how I want the replacement shapes to be positioned with respect to the matched shapes. I now copy the Highway 880 sign into the MatchTool, and now my entire replacement pattern has been specified. Further down on the MatchTool, there are 4 buttons labeled Search, Yes, No, and Change All. In a moment, I will use these buttons to change the Highway 17 signs into 880 signs. I move into the gargoyle window, and I place my software cursor called the caret. The MatchTool begins searching at the caret and proceeds downward. To start the search, I will hit the search button that I pointed out before. The MatchTool finds the first Highway 17 sign, and if I click the Yes button, it replaces the 17 sign with an 880 sign. I will click Yes again, and the second sign is replaced. Since Highway 17 has only been renamed north of 280, I will now click the No button, and we are done. Let's use the MatchTool to make a fractal snowflake. At the bottom of the gargoyle window is an equilateral triangle. We're going to replace each segment of the triangle with 4 smaller segments, as shown at the top of the viewer. The arrows drawn on top of the lines show the direction in which they were drawn. We will use this information to guide our replacement operation. As before, I will load the pattern into the MatchTool. First, I copy the line segment into the search pane. However, this time I have some additional search parameters to specify. I not only want to search for shapes that look like the shape in the search pane, but I also want to search for rotated versions of that shape. I indicate this by selecting the Rotation Invariance option. I would also like to search for versions of that shape at different sizes. I indicate this by selecting the Scale Invariance option. At this point, my search pattern is ambiguous. A line segment can match another segment at 2 different orientations that differ by 180 degrees. To prevent this, I activate the Polarity option. This tells the MatchTool to match 2 shapes using the orientation that aligns the directions in which they were drawn. Finally, because we are searching for only part of an object rather than the entire object, I must set the granularity of the search to the finest level. Now, I align the replacement shape with the search shape and copy it into the Replace pane of the MatchTool. I place the caret above the triangle, and this time I will hit the Change All button. Notice that all 3 segments of the triangle are replaced each by the 4-segment pattern. To get a fancier snowflake, I can hit the Change All button again. Because the Scale Invariance option is on, the MatchTool finds the new shorter line segments and replaces each of them with a smaller copy of the replacement pattern. The Match tool can be used to change some properties of the matched shapes while leaving others intact. For instance, if we would like to make a multicolored fractal snowflake, we might start with a multicolored triangle, as shown here, and instruct the Match tool to replace the shape of each segment as we did before, but to leave the line color alone. To do this, we use the Search and Replace columns of the Match tool. The black boxes in the Search column indicate what properties of the scene shapes must be the same as the shapes in the Search pane for a match to occur. As you can see, we are currently looking for objects of the same shape, object class, and curve type as the search pattern. All other properties will be ignored. In particular, we do not care what line color the scene objects have. Hence, our search pattern will match all of our differently colored segments. The black boxes in the Replace column indicate what properties of the shapes in the Replace pane will be transferred to the matched shapes. Currently, all properties of the replacement shapes will be transferred. However, if we turn off, for instance, line color and line width, then these properties of the matched shapes will be left alone. Let's try it. I'll place the caret above the triangle and hit Change All again. Shape is replaced as before, but this time the line colors are left alone. The Match tool is well suited to making recursive shapes like the snowflake curve. Here is another example. I will search for a black bordered rectangle and replace it with a solid black rectangle and two black bordered rectangles. I tell the Match tool that area color and line color are important for the search, and that it should match objects at different rotations and at different scales. In the gargoyle window, I begin with a single black bordered rectangle. I click Change All to perform the substitution. I have activated scale invariance and rotation invariance, so if we repeat the Change All, the Match tool will find the new smaller rectangles and replace them with still smaller rectangles. The result is a binary tree. This method of creating complex shapes using replacement rules is called graphical grammars, because the replacement rules are like productions in programming language grammars. As this example shows, graphical grammars can take advantage of the ability to search for object color as well as object shape. Graphical Search and Replace is also useful for getting more use out of old pictures. This time, we begin with a set of line patterns that I have in my library: a spiral, a hexagon, a regular array of line segments, and a random collection of line segments. We have set up the Match tool to replace each line segment with a star, as shown at the top of the window. With the Match tool and a library of line patterns, we can easily position arbitrary shapes in any number of patterns, regular or random. We call this technique graphical templates. Graphical search can be combined with operations other than replacement. For instance, we have built a graphical macro facility that performs a set of editing operations on each set of matched objects. Here, the Match tool is searching for a box or an ellipse. When it finds one, it performs a graphical macro operation that copies it, turns the copy gray, and moves the copy underneath to give the object a drop shadow. In summary, Graphical Search and Replace can be used to make coherent changes to a picture with repeated scene elements, can create recursive shapes using graphical grammars, and can position shapes in predetermined patterns using graphical templates. Shapes can be found at arbitrary orientations and sizes. The user can select which graphical properties of a scene are important for each search and which graphical properties of matched objects will be replaced. Graphical search can also be combined with a set of remembered operations to produce a graphical macro facility.